So this session will start with the concept of a plane. What is a plane? The formal definition of plane is a surface which can be extended indefinitely in any direction. So this ABCD is not a plane, it is just a section of a plane. If you extend this way, it goes up to infinity. Extend this way, it goes up to infinity. This way, so it has no length, no breadth, and its dimension equal to 0. Plane is a surface which can be extended in any direction, but thickness of the plane will be equal to 0. So question arises, is this a 3-dimensional object or 2-dimensional object? Then go for another definition of plane, that any 2 points on a plane or a surface to join, the line segment lies completely inside the plane, inside the surface, then it is said to be a plane. Any 2 points you take, you join them by a line, that line will completely lie inside this surface only. Then it will be considered a plane. For the concept of planes, they are parallel. If you take 2 planes this manner, so that there is no point common, then they are said to be parallel. You can define it with different manners. If there are parallel planes, they have the same unit normal. Unit normal is what? Which is perpendicular to both. Unit normal, if you draw, then it will be unit normal to plane 1 and it will be unit normal to plane 2 also. It means it is normal to both the planes. Okay? So this one is, these are 2 parallel planes. They have a normal common to them. Normal to first plane pi 1 is normal to second plane p 2. So this way you will get idea of plane. And you can see that plane contains infinitely many lines. They may be parallel. What's the concept of parallel lines here in 3 dimensions? You cannot define it in a space. If you want to define 2 parallel lines, they must lie in the same plane. Then only you can say parallel. Okay? They are lying in different planes. Imagine these 2 lines. They also look parallel. But in 3D, we will define 2 parallel lines if they lie on the same plane and parallel to each other. I mean, same direction they have, then they are parallel lines. Now, what is the equation of plane? See, in class 12 syllabus now, you are learning 3D with the help of vector. So, let us approach the equation of plane by using the concept of a normal drawn to a plane. Imagine there is a plane and a normal drawn to it. What is normal? It is perpendicular to the plane. And that normal can be shifted anywhere. In any, parallel direction you can shift it easily. Like, imagine this one going to be a plane. The unit normal drawn to the plane will be perpendicular to all the lines in the plane. Not only they are passing through this point. We will say that they are line, not line segments. These lines need not pass through the foot of perpendicular, because this unit vector you can shift in any direction. Okay? So this normal exists everywhere in the plane and it is perpendicular to all the lines. So I introduce the concept of unit normal drawn to a plane. What is that? The unit vector can be slid parallel to itself. So unit vector drawn perpendicular to the plane is unit normal. Okay? Now, what will be the equation of this plane? Let me take a three-dimensional coordinate system. X, this is Y, and Z axis is there. Okay? I am taking this plane here in this three-dimensional coordinate system. Maybe directed any manner. So I am drawing the plane like this. And we are supposed to find the we are supposed to know the unit normal drawn to the plane. Suppose this is given as n cap, and this equation of the plane you have to find, where distance of this plane from the origin is known. So imagine the wave plane is situated here. This plane is not passing through origin. We can take the plane this manner also. For your convenience, probably you will understand better if I take the plane this manner. Just drawing a plane like this. This is not triangle. This is a plane. And this plane intersecting all the coordinate axes. This is not triangle. This is a plane I am telling you. X, Y, Z axis. Intersecting here at A, here at B, and here at C. Equation of this plane we are going to find in terms of unit normal. So what I am doing here first, imagine on this plane we have taken a point P, X, Y, Z, and its distance from origin is D. Okay? This perpendicular distance from origin is D. So unit normal, this time you have to take that manner only, because that direction will be along the unit normal. So I am taking unit normal this way. Imagine this is a normal drawn to the plane in 3D. You are doing it in 3D. You want to find the equation of the plane now. So point may lie here. From origin distance is d. Unit normal may go this manner. Then you have to write equation of this plane. How to write? When you are going to find, do not take a point at your convenient position. It may be an arbitrary point. This point P is an arbitrary point on the plane. Its coordinate going to be x, y, z. And then A is a point on this normal, this perpendicular. This is perpendicular to the plane. Join O to P also. Okay. Now A and P lie on the same plane. To join them by line segment, then definition I told you, this normal is perpendicular to the line segment, isn't it? This unit normal is perpendicular to all the lines in the plane. It is perpendicular to this line segment also. Don't take it as A because the point A is taken here. You take this one different. Set D. And this D has distance equal to D from the origin. So, if you write OD in the vector form, this is going to be what? D into n. This follows from idea of the unit vector. Okay? So, OD you know, OP you know. OP is what? OP is xi, yj, zk. This we are taking as R. So, what about dp? Position vector of P minus position vector of D. R minus D into n cap. This dp vector is perpendicular to the normal drawn here, isn't it? This is perpendicular to the normal drawn here. So, a PD is perpendicular to n cap. By using cross product, this will be R minus D into n cap. By using dot product concept, this should be equal to 0. So R dot n cap dot n cap equal to 0. So R dot n cap equal to D. This is the vector equation of a plane. You have seen that vector equation of a line. If a line parallel to vector B, then equation is R equal to A plus TB, where the point on the line is A. But here, what we have defined a plane. That plane has a unit normal and perpendicular distance of the plane from origin is D. See, most of you have passed class 12 or you have appeared 12, that's why you are appearing WBJEE. Concept of plane is very important. It's I will not say very easy topic, but it can be understood and excellent, but you need to learn it with slowly. So let us pay attention on the vector form only. This we have derived equation of plane whose perpendicular distance from the origin is D and unit normal drawn to it is along in cap. Okay. So equation of plane whose perpendicular distance from the origin is D and unit normal drawn to it is n cap is given by this equation. Understood? So imagine once more, this is the plane, origin is there, its distance from origin is D and unit normal, this is perpendicular distance, so unit normal will be directed this manner along in cap and arbitrary point we have taken as R. This perpendicular distance is D from origin. Then equation of the plane is R dot in cap equal to D. This is vector form. Vector form of a plane. Now let us do one problem based on this concept. First, so we have to find to write the equation of plane. Equation of plane whose perpendicular distance from the origin is 7 units and a vector perpendicular to it is along Ti plus 4j plus 5. Okay. Find the equation of plane whose perpendicular distance from origin is 7 units and a vector perpendicular to it is along this. We will be using this equation. R dot in cap equal to D. I am going to do that. Okay. R dot in cap equal to D. Use the equation R dot in cap equal to D here. Direct. The required equation is, you keep R in terms of R only, write the unit vector Ti 4k by is equal to 7 root. So R dot Ti 4j 5k, this is coming root 55. You can leave it here only. This is the required. I am simplifying. The equation is this. This is R dot Ti 4j 5k is equal to 70. Clear? Understood? So this is the equation of plane. unit normal down to the plane is there, we can leave it there or this way. But now we will be interested to know its scalar form. What will be the scalar form of this plane? To get the scalar form, we are taking r equal to, r is an arbitrary point, yj, zk. In cap, we are taking li, nj, nk. This n differs from this n. N cap is uninormal down to the plane and this is n. So substitute there. R dot n cap is what? Lx plus my plus nj. Therefore, required equation is Lx plus my plus nj is equal to d. Just check once. This is the required equation of the plane. Lx plus my plus nj is equal to d. Now, both the forms I told you here are known as normal form. We have written vector equation in normal form. We have written scalar equation also in normal form. So whether you are writing this or this, these are called normal form. Normal means perpendicular. So for this plane, LMN are known as direction cosines of the normal drawn to the plane. Agree or not? Element, these are called direction cosines of the normal drawn to the plane. So now we dare to keep the answer in terms of direction ratios also. Just I tell you to write this manner. Let direction ratios be A, B, C and D. No, A, B and C. Then L is what? You know, A by root over sigma square, M, B by under root sigma square, N. So required equation going to be, if you put all these values there, X, dy, Cz, d multiplied by sigma square. This scalar quantity, ABC are all scalars. So you can write, if you take it on the left side, that general equation of the plane is going to be of this form. This plus d equal to 0. We have taken this thing on the left hand side. Okay? X plus by plus cz plus d equal to 0. This is the equation of plane in scalar form. So we can create one thing from here. A first degree equation in xyz always represents a plane. Okay? This one is a first degree equation in xyz. It will always represent a plane. Ax plus by plus cz plus d equal to z. Never forget that. These ABCs are direction ratios of normal drawn to the plane. If you want to express this manner, Lx plus my plus nj is equal to small d, some books they write this. Equal to p, then this is the normal form and element are disease of normal drawn to the plane. And what about P? P is the length of perpendicular from origin. I am just telling because in some book you will find it. So either this or this equation of plane or vector form r dot n cap equal to d. So far we have learned these three equations of plane. Okay. Now let us make a few observations here. Suppose a problem given this way. Find the perpendicular distance of the plane, say x plus 2y plus 2z minus 10 equal to 0 from the origin. The NCERT has introduced the concept of 3D by using vector. So there is a definite aim. If you learn vector form, if you once be adjusted with vector form, will be beneficial. So I will suggest you to write the answer here by expressing it in vector form first. How to express in vector form? Because these are direction ratios. So in the very first step, what I am going to do, divide both sides by, because these are direction ratios, 1 to 2, if you divide by this, then you will get direction cosines. What do you get? 1/3 x, 2/3 y, plus 2/3 z. Now what about this form? This is of this form only. Why? Because 1/3 square, 2/3 square and 2/3 square, their sum is 1. Yet their direction cosines. Why? Because sum of these three squares has to be 1. These are direction ratios. Why? Because sum of squares here is square plus b square plus c square is not 1. Once we divide by root over a square plus b square plus c square, then we will get the normal. In fact, I have discussed how to convert this general equation of plane to normal form. How to? To get this form, divide both sides by always. Then you will get this form directly of the plane. So I have done that only. The advantage is once you get this form, then right hand side will be P or D, whatever you have stated, 10/3 unit. This was the question. Clear? Understood? Let us do one similar problem, because this is concept building class, isn't it? Taking another example here, find the coordinate of the, hope you all are doing it with me, find the coordinate of the foot of perpendicular drawn from origin to the plane, say 3x minus 2y if you have understood the concept of plane, this you can manage yourself. Okay? Coordinate of foot of perpendicular drawn to the plane, to this plane, you have to find it. So what I am doing here first, for better concept, I am trying to give you the position of the plane. Okay? Plane will be something like this here. Okay? From origin, you have taken a perpendicular. Okay? You are going to find the coordinate of this foot of perpendicular. This P be the foot of perpendicular, let P be alpha, beta, gamma. Okay? This is your origin. And what are direction ratios of normal drawn to the plane? Pairs of the normal are 3, minus 2 and 4. This is the origin. Direction ratios of normal you got here, but this is in the direction of normal only. So if the point is alpha, beta, gamma, then OP is along in cap. OP vector is along in cap. What are DRs of OP? Origin is 0, 0, 0. Pairs of OP are what? Alpha minus 0, beta minus 0 or beta and gamma. What are DRs drawn to the plane? 3, minus 2 and 4. So these quantities must be proportional. Therefore, gamma by 4. Hope you all agree. Okay? Now assume this thing equal to m. So alpha will be what? M beta minus 2m gamma 4m. Okay? Now equation of plane is this, and these 3 points will be lying on it as P alpha beta gamma lies on the plane, so it will satisfy. Plus Understood? Let us solve it. 25 and 4, 29. So AM equal to 15 by 29. You got the points now. Therefore, P will be what? Same. Beta will be what? Minus 2m. And gamma, 4m. Is that clear? So concept is based on the concept of understanding direction issue, direction cosine. Just one additional thing has come here. R dot n cap equal to d. This d is the length of perpendicular drawn from origin to the plane. Isn't it? Now, we are going to learn equation of plane. Sometimes these forms help, but the main topic we have discussed. Here, just for direct answer to the question, where you have to write equation of a plane whose perpendicular, which is perpendicular to a given vector, which is perpendicular to the vector n and passes through a given point A. Okay? This we are going to find. The equation of plane. Do you find any similarity with straight line? Passing through this and slope of the line is this. Then equation y equal to mx plus c. You can remember this way, but same things are not there, definitely. But if you want to find a coincidence, like that, what will be the equation? So let me take a plane first. This is our plane. A vector, if perpendicular to the plane, then it is perpendicular to all the lines of the plane. This we have learned. Okay? This be our origin. And an arbitrary point on the plane is A. That is given. OA. Okay? O2A we have done. Now, this point has known position vector. Okay? An arbitrary point always you have to take, that you have seen in case of straight line in 2D and 3D. It was xy in 2D, xyz in 3D. So you always take the arbitrary point whose position vector is R. Now join A and B. This is the origin. OP is the vector R. OA is the vector A. You have to write the equation of this plane. So AP perpendicular to n. What does this imply? AP dot n equal to 0. So R minus A dot n equal to 0. This is the equation of the plane. Somebody has given you the vector A and n. You can write the equation. Okay? Similarly, how you write? This is vector form. Scalar form will be what? This one is the vector form. and scalar form now I am going to discuss on it. That point A you can take x1, y1, z1. Then OA vector will be what? OA is a vector only. x1i, y1j, z1k. A vector. R vector is what? Arbitrary point. So R minus A will be what? Y minus y1j plus now is the dot product here. That in cap you take this manner. It is not unit number, it is a vector. Let us take this one as AI bj ck. Put r minus a dot n equal to 0. So x minus x1 I, y minus y1 j k dot ai plus bj plus ck equal to 0. So this is going to be changed to what? Okay. This is called one point form. There is a name over there. The one point form of a plane. One point form of straight line you have studied. This is one point form of a plane. Vector form r minus a dot n0. Scalar form is this. Just remember this. Okay. Let me write one sum here. Read the question and start. Do it with me, you will learn it. Question is this. Write the equation of plane passing through 2, 4, 7 and perpendicular to a line of bears 1, 4, minus. So we will be going by this form. Direct answer. How? They have given A, B, C and x1 and z given. So required equation is 1 into x minus 2, 4 into y minus 4, x plus 4y plus 5 equal to 0. So simple. Okay? Can you write the vector form here? Yes. Once you get one form, we can convert it into other form very fast. R dot n cap. N is what? Finished. This is not n cap, this is n. R dot n equal to this form also I have given, no? I have written there r minus a dot n 0, I will use that. Okay? So keep it this way. If you want to express this one in normal form, it will be r dot 17, 9, 26 r dot, if this you never express in minus, put this. Plus minus sign you keep here better. Okay? This is the required equation of the plane. But once you are expressing r dot n equal to d, that d will represent a positive quantity. That you never express in negative. It will be 5 by root 26. Here you keep r dot n cap. Okay? Now, this will encourage you to get the equation of plane passing through 3 points. Why not 2 points? Equation of line was possible by using 2 points only, but plane no. That's why 3 points. 3 points will determine the equation of a plane. 3 collinear points will decide the equation of a line. And 3 non-collinear points in a plane will decide the equation of the plane. Okay, this blackboard is the plane, or green board, whatever you say. Your problem is to write the equation of plane which contain these 3 points A, B and C. Okay? So how to get this? Always we write this is 3-point form. So equation of plane passing through 3 points A, B and C. Okay? A, B and C. To find the equation you need a arbitrary point. Take P as the arbitrary point. Okay? Take P as an arbitrary point on the plane. Okay, ABC given point and this is arbitrary point. It can lie anywhere. Now there is a origin in 3D, 2D, whatever. 3D. There is a origin. This is vector A. This one B. This one C. And this one B. R. Okay. This is R. Now, the plane you are going to find whose equation that contain all the 4 points. This is the plane. It contains all the points A, B, C and R. But the idea so far we got, we need a normal drawn to the plane. What is the normal? In cap or in? If you write in cap, then it is R dot in cap equal to D. If you take in, then it is R minus E dot n equal to 0. Although one form can be changed to other form, but in and in cap, they are same thing. Unit normal can be obtained easily, but here no perpendicular given. How do you find it? You can state by using this thing, plane passing through a point. This will help you. I will show you that form. You can use this form also. R minus E dot n equal to 0. You can find n by using the concept of cross product of vectors. Okay? Now, I am just telling you one thing. These are two vectors, AB and BC, or BA and BC. If you know 3 points in a plane, you can write the equation of normal. How to? Because BA cross BC is perpendicular to the plane given. Okay? And A is a known point over there. So why you are not taking the help of this form? N is the vector that we got here. This will play the role of n. So if I tell you the required equation is, I am using this one point form, R minus E dot BA cross BC equal to 0. This will be justified. BA is what? Position vector of A minus that of B. BC is what? Position vector of C minus position vector of B. BA cross BC, this thing. R minus A dot n 0, n we got here. This thing you can keep in bracket. I am not going to simplify it, I am just showing you the method. This is the method. That by using one point form only we are getting. Okay? You can get it by scalar form also. Scalar form equation of plane is this. You can take the help of it. So let me do it. Scalar form. Next one is 3-point form, but this time scalar form. How to get? Start this manner. Those points you assume first. Okay? Scalar form. 3 points given. So you start this manner. This form. 1 point known, ABC known. Here is not known, but we can assume. Let the plane be driving. Driving means it's a problem. Solving. Let the plane be plus C into Z minus Z1 equal to 0. Number 1. It passes through this point. So it will satisfy this equation. You put it here. And it passes through this point also. A into B into okay. You need to eliminate A, B and C. Eliminating A, B and C. What will you get? We'll get this form. Y minus Y1 this is the required equation of plane in scalar form passing through 3 points. Hope you have understood. So let us solve one problem based on it. Write both scalar and vector form of a plane passing through 3 points. We'll do it. Write the equation of plane passing through P, you take AB. 1, 2, 4, B 3, 2, minus 1, C 2, 4, 7. Passing through these 3 points. So put this form directly or go by vector form first. Vector form is what? R minus A dot N equal to 0. A is what? I. N is what? Perpendicular to the plane containing 3 points. I remind you again. A, B and C. 3 non-collinear points will decide the equation of plane. Why? Because n cap you can get very first. BA cross BC perpendicular to the plane. So A will be, if you see that there is no choice, I can take AB and AC. Yes, of course you can take. So N is any vector perpendicular to the plane. So N will be along AB cross AC. Okay? And A is a known point. So R minus I 2J 4K dot AB cross AC. What is AB cross AC? You write the AB vector 2I minus 5. AC vector is what? You know how to find? I 2J 3K. Then find AB cross AC. I JK 2 0 minus 5 1, 2, 3. Find this by cross product method. Minus 10i minus 11j, and this is 4 minus 0. So I have found this part is minus 10i minus 11j plus 4k equal to 0. Okay? Vector form you keep this way. From here you can easily write the scalar form or use the determinant form. That is x minus x1, y minus y1, z minus z1, like that. Or do it from here. How to? This is x minus 1i, r is x, y, x, I, y, z, z, k, y minus 2j, dot this thing. Okay? Take the dot product. Minus 10x minus 1, 11y minus 2, this is the required equation. Use determinant form or this form directly. This way, you can write the equation of plane in both scalar and vector form. Now, what is the intercept form of a plane? Like intercept form of a line. Intercept form of a plane. How to get it? Intercept form means with x, y and z axis, whatever intercept it makes, that will be fine. So you start this manner. Let the plane be x, by, plus d equal to 0. How to get its point of intersection with x-axis? For x-intercept, what to do? Put y0, z0. So x will be what? Minus d by a. If I take those 3 points on the plane as P, B, and C, this is y axis. Then this is value of E. Similarly, you put x0, z0, y will be what? This is minus, y is minus d by b, that is b, small. And z is what? This C. Okay? Now what will be intercept from then? These 3 points you got, A, B, C. So every time divided by D, rewrite this equation here. Okay? Divide both sides by minus D or D minus D. Write x, by, divide by minus 3. So x by a, y by b, z by c equal to 1. Hope you have understood. Equation of plane in intercept form is x by a, y by b, z by c. This part is a, this part is b, and with z axis. And what is the plane here? This is the plane. PQR. PQR is the plane. This is not triangle, plane. Okay. So what will be equation of xy plane? What will remain absent from xy plane equation? If xy plane is there, then which part will be 0? Xy plane means it will be z equal to 0. Only z equal to 0 will tell you the xy plane. No z will be there because plane equation is this. Equal to 3 or minus 3 plus 3 equal to 0, whatever. So x equal to 0 is the equation of this plane, which is yz plane. Xz plane, here y is permanently 0, here z is 0. The xy plane. Okay. So this is the first part of plane I have explained today. Let us you practice few sums, coming back with the next topic.